What kind of experience would that be? About 4.6 billion years ago, diffused gas and dust in the solar system contracted over billions of years, and through continual collisions and accretion of planetesimals, our Earth finally took shape. But the Earth was extremely hot then, with no solid surface, only vast, boundless molten lava. Temperatures even exceeded 200 degrees Celsius. 4.5 billion years ago, a planet named Theia collided with Earth. Its shock waves spread rapidly, blasting vast debris into space. Under the impact and subsequent accretion, our moon eventually formed. Because of this violent collision, Earth's rotation at that time became extremely fast. A day lasted only 6 hours. Over the next 300 million years, as asteroids and comets pummeled it with impacts, Earth endured a hellish bombardment. Meanwhile, heat from volcanic eruptions and meteor strikes also brought large amounts of water. Thus, torrential rains fell for millions of years. Finally, around 4.2 billion years ago, the primordial ocean formed, turning Earth into an ocean world and creating conditions to nurture life. Around 3.9 billion years ago, life first appeared on Earth. It was the origin of all things, a single-celled organism called LUCA. Time then moved to about 2.6 billion years ago. By then, terrestrial lavas had erupted for millions of years. Vast toxic gases filled the sky. Earth was shrouded in massive methane clouds, giving the planet a yellowish appearance. Yet plankton appeared in the oceans. Their cellular structures were more complex. They even evolved photosynthesis, producing and accumulating large amounts of oxygen, transforming Earth into a blue planet. This was the Great Oxidation Event. Because of this event, greenhouse gases in the atmosphere were greatly depleted, causing global temperatures to plunge. Around 2.4 billion years Earth underwent the Huronian glaciation lasting tens of millions of years, during which the progress of life stalled. Earth became a snowball. As submarine volcanism released large amounts of greenhouse gases, they gradually melted. The glaciers and gentle sunlight once again bathed Earth's oceans. Over the following hundreds of millions of years, evolution proceeded very slowly, until one day about 1.6 billion years ago, a bacterium and an archaean accidentally merged, gradually evolving into eukaryotes. A great miracle in the history of life on Earth. Time moved to 600 million years ago. Eukaryotes finally underwent an explosive diversification. Many soft-bodied multicellular invertebrates appeared. They formed the unique Ediacaran biota, facing abundant resources and favorable environments, and with few natural enemies. Organisms of this period settled into stability. Eventually, around 540 million years ago, the emergence of arthropods became a nightmare for these lower invertebrates. They advanced over the remains of Ediacaran creatures and pressed on, opening the first grand curtain of Earth's biological history, the Cambrian explosion of life. The oceans teemed as never before. The first overlord, anomalocaries, hunted with abandon, relentlessly on the prowl. Armored trilobites were also lying in wait, and creatures like Opabinia, sea scorpions, Euryptenia, and other bizarre forms. At the same time, the earliest vertebrates on Earth appeared. A fish-like creature called Hekoshis. Thanks to their presence, the ancient oceans became this spectacular. Time moved to 510 million years ago. The land was still barren, unsuitable for life, but along coastal margins near the sea, some species began to take the first challenge. First, a composite organism of algae and fungi lichens, this remarkable partnership could conquer these impoverished lands. Its greatest feat was sending hyphae deep underground, slowly breaking down hard rock, thus giving Earth its first soils and paving the way for later plants. Soon, the first land plants mosses appeared. Their leaves had only a single cell layer. They could not grow upward, but spread forward with astonishing speed. In a short time, they carpeted whole continents, and for the next 40 million years, were the sole overlords of the land. Next, let's jump to 468 million years ago. By then, the oceans had changed dramatically, unfolding a brand new era of life, the Great Ordovician Biodiversification Event. Compared with the Cambrian, animal diversity and abundance multiplied several-fold. Mollusks flourished, and life and death duels played out constantly. The trilobite clan still persisted, their armor growing even tougher, while their enemies became more terrifying. Orthocones up to 9 meters long defeated anomalocaries, becoming the new rulers of the seas. At the same time, another crucial new lineage arose. The earliest fishes, the first vertebrates on Earth, the ostracoderms. They would eventually give rise to amphibians, reptiles, mammals, and birds. But humanity's earliest ancestors were still only at the very beginning of a long journey. As time flowed on, by 460 million years ago, vascular plants on land successfully evolved lignin, allowing them to grow thicker and taller. Competing for sunlight, they entered fierce rivalries. A stunning botanical boom had arrived. Unexpectedly, amid more than 20 million years of prosperity, as life flourished, Earth experienced its first mass extinction. The Ordovician mass extinction, around 445 million years ago, a rapid drop in atmospheric carbon dioxide removed the blanket of greenhouse gases, driving the climate to extremes. Seawater cooled swiftly and froze, turning over half the globe into glaciers. Beneath the beautiful, sinuous ice crystal patterns lay graves for all things. About 85% of species perished. Yet some hardy organisms moved into the deep sea, keeping life's spark alive. Nightmares end eventually. Roughly 2 million years after the Great Freeze, global temperatures began to rise. A magnificent thaw commenced. Over several millennia, almost all glaciers vanished. Earth returned to deep blue and entered the Silurian, an age of recovery. During this time, it took more than 20 million years to heal the wounds left by the Ordovician mass extinction. And it also nurtured a great transformation. As Earth's temperature rose, plankton began to reproduce in huge numbers. Armor-clad arthropods still ruled the seas. During this time, the once inconspicuous vertebrates began a quiet rise. Over long ages, they evolved movable jaws. Finally, about 400 million years ago, with the explosive radiation of fishes, Earth formally entered the Devonian period. In the oceans of this era, vertebrates found a paradise. Jawed fishes displayed striking diversity, and fishes as a whole became highly varied. Among them, the placoderms armored fishes were best suited to become the period's dominant apex marine predators. They could reach 10 meters long and 4 tons in mass, clad in exceptionally tough armor, with a terrifying bite force. They could crush even extremely hard boulders in a single snap. Armed with astonishing jaws and flexible backbones, this perfect combination let later vertebrates surge ahead. Meanwhile, land was no longer just simple mosses and naked early plants. Vascular plants grew into towering trees over 10 meters tall. Forests swarmed rapidly, and soils and atmospheric composition improved. Life on land began to bud. The earliest arthropods to come ashore became the first overlords of these primeval rainforests. Then, one day about 370 million years ago, a major miracle in evolutionary history occurred. A low-finned fish that breathed with lungs, under constant pressure from placoderms, crawled onto the beach for the first time, achieving landfall. Because of this, in time it founded the greatest radiation of terrestrial vertebrates. All the birds and beasts we see today, humans include, descend from this lineage. Perhaps because Dunkleosteus was too dominant, nature resolved to reset the game. Around 360 million years ago, submarine volcanism and mantle plumes erupted in succession. Scalding magma rapidly raised ocean temperatures, turning once thriving seas into a terrifying purgatory. Half the fish lineages failed to survive, though Dunkleosteus endured. Until next came an explosive rise in plankton, which drove a sharp drop in oceanic oxygen. The once invincible Dunkleosteus vanished from the stage of history, and about 75% of marine species died. Coastlines around the world were littered with the remains of life. This was Earth's second mass extinction, the late Devonian extinction. Meanwhile, on land, a different scene unfolded. We enter the Carboniferous about 345 million years ago. The continents were not as scattered as today, but in the process of coalescing. Vast tropical rainforests clustered there, making the climate warm and humid, with lush forests and swamps everywhere, which in turn led to atmospheric oxygen reaching an unprecedented peak, with concentrations even twice today's. This had profound effects. During this period, many extraordinarily large arthropods emerged, colossal in size. For example, giant dragonflies larger than eagles, giant centipedes over a meter long, and millipedes up to 3 meters, with a notoriously fierce temperament. Hence, the Carboniferous is also called the Age of Giants insects. The lobe-finned fishes that had already made landfall evolved into tetrapods with 4 limbs, becoming apex predators of Carboniferous waterways and marking the official beginning of the Age of Amphibians. Around 320 million years ago, Earth's continents gradually merged into a single supercontinent Pangaea, drying out the continental interior. The vast sun-blocking forests broke apart, rivers and swamps nearly vanished, and great tracts of land turned to desert. Oxygen concentrations fell sharply, and those giant insects ultimately went extinct as they failed to adapt. This was the Carboniferous rainforest collapse. Amphibians that needed to lay eggs in water faced shrinking water sources and evolved in response. The outer membrane of the egg gradually became a hard shell, allowing eggs to be laid on land, creating Earth's first amniotic eggs. At the same time, some amphibians evolved into amniotes, which freed them completely from dependence on water sources and let them explore farther afield. Thus, Earth entered the final epoch of the Paleozoic, an era of rampant giant beasts, the Permian. As time went on, by 300 million years ago, amniotes already covered all of Pangaea and split into 2 great lineages, synapsids and sauropsids, 2 great dynasties whose endless struggle began in earnest. At that time, sauropsids such as the parasaurs were still relatively weak. Though up to 3.5 meters long and heavily armored, they were plant eaters. By contrast, the synapsid Gorgonopsians became the top predators of the Permian. They exceeded 3 meters in length, with canines up to 15 centimeters, preying on parasaurs and other sauropsids. Though synapsids were in their heyday, there were exceptions, such as the timid dicynodonts, who would bolt for their burrows at the slightest rustle, a trait that may have helped them survive the cataclysm to come. Time marched on to 251 million years ago. With a tremendous roar, a supermantle plume beneath what is now erupted beneath the sea. Massive quakes tore open the oceanic crust, triggering activity across the Siberian volcanic region. In response, trillions of tons of magma surged from the mantle, spreading across the globe at frightening speed, ultimately engulfing half of Pangaea. Some animals escaped the first blow, but the disaster was far from over. Volcanic ejecta fell like rain, sparking continent-scale wildfires, shattering food webs, and collapsing entire ecosystems. Animals died in their struggles, and Earth fell silent. This was the most devastating event in history, the Permian mass extinction. In this cataclysm, not only were up to 95% of species, but for a time the biosphere, sculpted by billions of years, was nearly undone. The biosphere, shaped by billions of years of evolution, was ruined in an instant. Fortunately, life still retained a sliver of hope. Fungi were the first with remarkable adaptability to take over the post-apocalyptic wasteland. After tens of thousands of years of recovery, around 250 million years ago, Earth finally raised the curtain on the Mesozoic. In the early Triassic, after the mass extinction, there were almost no large predators, allowing the dicynodont lineage to flourish, rising from the bottom of the food chain straight to the top. During this time, the dicynodonts made up 3/4 of all land vertebrates, a feat no other animals had ever achieved. Yet such dominance would not last long. As Triassic landscapes changed, temperatures over Pangaea began to soar, with the continental interior reaching up to 60 degrees Celsius, creating the largest deserts in Earth's history. Across ages, few animals can survive in true deserts, but lizards proved an exception. Their powerful adaptability let them rise out of the sands. By about 248 million years ago, once unassuming small lizards had gradually evolved into formidable archosaurs, not only with stout defenses, but also powerful predatory skills, treating the dicynodonts that had ruled for nearly 4 million years like a buffet. Thus began the true age of reptiles. A great variety of reptiles appeared in succession, making competition on land intense. Persistent drought also pushed global temperatures to a critical point. About 234 million years ago, deep within the parched heart of Pangaea, a long-awaited deluge fell. A 2 million year humid interval completely reshaped the continent. The famed Carnian pluvial episode. Low, green plants sprang up like bamboo shoots after rain, turning arid land moist, and grasslands gradually into forests. A major turnover in Earth's fauna began. Short, drought-adapted grazers couldn't adapt to the new conditions and drifted toward extinction, while turtles and mammals stepped onto the stage of history. Around 230 million years ago, the southern cross dragon appeared, shifting the course of evolution. At first, they were tiny, but as carbon compounds increased, they grew larger and larger until the archosaurs took center stage. Though Earth spent 50 million years repairing its ecosystems, it could not escape fate's verdict. About 203 million years ago, frequent tectonic upheavals triggered global volcanic eruptions, pumping vast amounts of carbon dioxide and methane into the atmosphere. The growing greenhouse warmed the climate and deoxygenated the seas, and 76% of species unable to cope ultimately vanished from Earth. This was the Triassic mass extinction. Luckily, the archosaurs, dinosaurs, were the ones history favored. In the Jurassic, 200 million years ago, the dragon clan rose to power. Pterosaurs and birds took to the air, mammals appeared, and astonishing evolutionary leaps followed one after another. Dinosaurs formally proclaimed their rule over Earth. Many representative creatures emerged. For example, the enormous Diplodocus reaching 27 meters. Pterosaurs that first conquered the skies, Liopleurodon, the brutal overlord of the oceans, Allosaurus, the apex predator on land, and Stegosaurus wielding its tail as a weapon. There was even one of the oldest eutherian mammals, Juromia sinensis, among others. The success of the dinosaur dynasty was not only its long reign, but how these remarkable creatures, with the environment's generous help, unfurled such a breathtaking pageant of life. About 145 million years ago, entered the Cretaceous, a burst of biodiversity, when countless brilliantly colored flowers appeared, using surrounding animals to spread pollen. So plant diversity reached yet another peak. At the same time, the dinosaur dynasty hit its zenith. During this era, colossal pterosaurs soared skyward, vying with other flyers for air supremacy. Semi-aquatic spinosaurs took to the water, contesting rivers with primitive crocodilians. Sauroposeidon, the largest land dinosaur, surveyed the world from on high. Giant crocs along the riverbanks lurked and waited. Microraptor flitted through the forest canopy. Therizinosaurus, with scythe-like giant claws, hunted cooperatively. The largest ceratopsian, Triceratops, locked horns in combat. Once humble lizards became colossal mosasaurs, ruling the Cretaceous seas. And Tyrannosaurus rex, monarch of tyrannosaurids, burst onto the dominating the Cretaceous continents. In short, life on Earth had entered a true golden age. Yet even such an unshakably powerful biological empire would eventually face a historic moment. About 65 million years ago, a Chicxulub asteroid, roughly 10 kilometers across, hurtled toward Earth at 70,000 kilometers per hour and struck in the sea off today's Yucatan Peninsula in Mexico. The blast from the impact was like 11 nuclear bombs. The violent strike incinerated all life within 1,500 kilometers, reducing it to ash. Over 3 trillion tons of debris were hurled into space, shockwaves racing at thousands of kilometers per hour, and a massive tsunami followed, sending countless animals to watery graves. Even if some large dinosaurs survived the first blow, the disaster was far from over. Soon after, incandescent ejecta rained back down, and the hot particles ignited continent-wide wildfires. On land or in the air, dinosaurs had nowhere to run. Dust in the sky blocked sunlight. For decades, plunging Earth into bitter cold. Plants withered as photosynthesis failed, and the surviving dinosaurs, unable to adapt to the shifting world, perished. Ecosystems collapsed completely, and Earth fell silent once more. Thus, in this merciless Cretaceous mass extinction, the most captivating era in natural history, the age of dinosaurs came to an end. After the cataclysm subsided, giant creatures were gone. Small mammals radiated swiftly, crocodilians pulled through, and whales' ancestors returned to the sea. In short, the survivors shared one trait. They were small-bodied and highly adaptable. In that previous glorious dynasty, they had occupied the very bottom of the food chain. Yet today, they've become the greatest winners. But the dinosaur bloodline was so powerful that even after countless years of extinction, it could still persist in another form. Around 62 million years ago in the Paleocene, the largest bird, Gastornis, inherited that dinosaur lineage. Bearing the will of the deep past, they again became rulers of the land after dinosaurs vanished. About 60 million years ago, tropical rainforests produced countless insects, which began to flourish and multiply. In doing so, they also spread pollen, paving the way for a future plant dynasty. Around 55 million years ago, the earliest true primates appeared. They were very small, only about 50 centimeters long, regarded as ancient relatives of humans, apes, and monkeys. At the same time, major mammal branches split. The odd-toed and even-toed ungulates finally emerged. Curiously, some even-toed ungulates returned to the oceans, becoming ancestors of whales. Among them, Pachyscetus was one of the oldest and most primitive whales. They looked dog-like, were covered in hair, lived mainly in freshwater, and preyed on fish. Although they could survive on land, they couldn't walk for long. About 34 million years ago, Antarctica grew ever colder, locking away vast stores of fresh water. Under these conditions, northern regions became drier, giving mammals a chance to rise. For example, Andrewsarchus, one of the largest terrestrial carnivorous mammals. Moratherium, an early semi-aquatic relative of elephants. Hyanodon, a huge and fearsome predator. Paraceratherium, the largest land mammal. Saber-toothed cats, close kin of modern tigers. And dinotheres, relatives of today's elephants. During this period, life began to take on a more modern appearance. About 21 million years ago, as the continents kept drifting, the Eurasian plate and the Indian plate pushed against each other evenly, in a long stalemate, uplifting the seafloor along a 2,500-kilometer suture line, ultimately forming the magnificent Himalayas and Mount Everest, the world's highest peak. Time then moved on to about 15 million years ago. By then, the Australian continent had drifted north for millions of years, and in the process, a vast shallow sea formed. A new cradle of life. Countless fishes thrived there, and the mightiest shark in Earth's history emerged. Megalodon, up to 20 meters long, weighing about 100 tons, with a bite force of at least 20 tons, easily crushing a whale's ribs. The strongest bite of any known creature. On land, global climate shifts ushered in an age of open plains and great grasslands, and over the next 10 million years, spurred another mammalian radiation. In this same period, primates split into two branches. One line evolved into monkeys, the other into chimpanzees. During evolution, chimpanzees diverged about 7 million years ago, intelligent beings. About 4.4 million years ago, the earliest upright walking hominids appeared, Ardipithecus. But because of many threats on land, they spend most of their time in trees, coming down only when hungry to forage. About 3.9 million years ago, Australopithecines evolved from Ardipithecus for survival, embarked on an unprecedented migration. Along the way, they were often hungry, frequently facing predators and natural disasters. The hardest time for our ancestors. At last, about 1.8 million years ago, Homo erectus appeared, giving humans powerful limbs and agile minds. They learned to use fire and various tools, and from primitive societies, kept evolving and migrating, spreading human footprints across Eurasia. In just a few centuries, they created miracle after miracle, and ultimately, humanity stood atop Earth's food chain and came to rule the entire planet.